Good afternoon, everyone. Today and tomorrow, as our wrap up to the exponential and logarithmic unit, we're going to look at solving exponential equations. Okay, so for part one of this today, I'm going to mainly review ones that I believe you would have seen in the grade 11 course. So this should be a bit of a refresher of how to solve equations like this. Okay, so example one, we have 3 to the x plus 1 is equal to 81. So my goal here, when I have these equations, is to get the equations to have the same base, okay? Because then I can equate the exponents and go from there. So for example, I try to think of, right, what power of 3 would give me 81. So right, I have my 3 to the x plus 1. Okay, and if we think about it for a little bit, maybe play around, we'll discover that 3 to the power 4 is equal to 81. Okay, now that I have the same base, right, they're both 3's, okay, I can remove them, and I have x plus 1 is equal to 4. And now I have a nice little linear equation that I can solve for x. So we bring the 1 over. That means x is 3. Okay, again, I can do a quick check by going back into the original equation. So we plug in 3 for x to the top. I have 3 to the x plus 1, which becomes 3 to the 4, and that does equal 81. We're good. Okay, example 2. Okay, 2 times, would be 2 to the power of 3x plus 1 equals 4 to the power of x minus 1. Okay, so again, let's make a little adjustment here. I can keep the 2 on this side. Okay, but on the other side, I'm going to have to set an exponent for that. So 4 is the same as 2 squared. Okay, this is a little different because I have another exponent here already, but that's when I remember my exponent laws. When I have power to a power, right, I just have to multiply those 2 powers together. So that means that I have 2 to the 3x plus 1 equals 2 to the 2x minus 2. Okay, and now we can remove the bases and solve for x. So we have 3x plus 1 equals 2x minus 2. Okay, we'll bring the 2x over to the other side. So I'm going to have x plus 1 equals -2, and then bring the 1 over to the other side. So x equals -3. Okay, on the next one. Okay, this is round 3. Okay, for here, okay, if I try doing 25 to the power of, right, 25 squared is already bigger than 125. So that's not going to work. So that means I want to see maybe if I can get a smaller base that will work with both of those powers. So if we try 5, okay, 25 is 5 squared. And 125 is 5 cubed. Okay, now we'll expand our exponents through. Right, I have to expand this in, and similar on the other side. So I'm going to have 5 to the power of 2x plus 8 equals 5 to the power of 6x subtract 27. Okay, now that I've got the same base, okay, I can equate the exponents. So 2x plus 8 equals 6x minus 27. Okay, I'll bring the 6x over, so I have -4x I'll bring the 8 across. I'll be negative 35. So divide both sides through, and we have x equals 35 over 4. Okay, next level here, I got root 32x equals 2 to the x plus 8. So, two things to deal with. One, 32 I can rewrite as the power of 2. So 32 becomes 2 to the 5th. Okay, which is good because my other side is already power of 2. Okay, the square root sign, to deal with that, we're just going to change that to its other form. Right, so square root is the same as power 1/2, okay, which is then to the power of x. Okay, so now tidying up the left-hand side a bit, I can multiply those exponents together. So I get 5 over 2x is equal to x plus 8. The bases will be the same now. Now, there's a bit of a jump there. Maybe I'll just throw in that's 2 to the power of that and 2 to the power of that. Okay, so that means I can drop the bases. Okay, and start solving for x. So again, I'll bring x over. So I have 3 over 2x is equal to 8. Okay, so 3x equals 16. X equals 16 over 3. Okay, and that's going to be it for today. So again, here's some practice work you can have a look at, or of course you can work on the assignment. Okay, and when I recorded this video, I didn't have the textbook with me, so this is my old list. If there's any changes, it will be in the supply notes, but those practice questions should most likely be good for this section. Okay, and then tomorrow we're going to move on to even more interesting exponential equations to solve. Okay. Thank you for watching, and I will see you tomorrow.